Assalamu alaikum ji. We are going to start with today's experiment, that is the paper 33, October-November 2023. This is the experiment in which you are going to determine the concentration of a solution of potassium manganate 7. Potassium manganate 7 reacts with excess acidified potassium iodide to liberate iodine. The iodine is titrated with aqueous sodium thiosulfate. You are provided with Fa1. It is an aqueous solution of potassium manganate 7. Fa2 is a potassium iodide 0.5 mole per decimeter cube solution. Fa3 is 0.120 moles per decimeter cube sodium thiosulfate. Fa4 is a dilute sulfuric acid, and Fa5 is your indicator solution, starch indicator. Now in this experiment you should know that there is a double reaction that is taking place, and both of them are the redox reactions. Potassium manganate 7 is acting as an oxidizing agent, will oxidize the potassium iodide in an acidic medium, in the presence of sulfuric acid, and converts the iodide into the iodine. This aqueous iodine that is liberated will convert the solution, the aqueous iodide ions, which are, you can see that this is the Fa2 solution, it is colorless. It's going to convert it into a reddish brown color of iodine. The liberated iodine is then going to be titrated by sodium thiosulfate. Sodium thiosulfate is a reducing agent which will convert this iodine liberated in the first equation into iodide ions. Okay, and itself sodium thiosulfate will be converted into tetrathiolate. It's sodium tetrathiolate that will be formed. Okay ji, let's begin. We are going to fill the burette with Fa3. The burette is in your burette stand. We are going to make this burette up in the upright position. Make sure that the tap is off. You will place the funnel on the top of the burette and add your Fa3 solution. The Fa3 solution is your sodium thiosulfate solution. This is added in the burette. We will fill the burette carefully. It's not necessary that you fill the burette up till 0. This should be on your own eye level. Okay. This is the extra amount. This part is the extra volume which is not graduated. Okay. Take off the funnel once you have filled the burette, and I have taken the extra amount off from the burette. Okay. This is your burette is now filled, and now I'm going to read the volume, and I'm going to make sure that the level is exactly at my own eye level. Right. This level, the reading on the burette is 2.1. So I'm going to record the readings. The table that is to be drawn is final burette reading. in centimeter cube. Initial burette reading and the volume of the solution that is added in the burette. We have taken Fa3 in the burette, so we will be taking the volume. We will be writing over here the volume of Fa3 solution used and the units. The first table that we are going to write down the values is for the rough titration. So the rough titer value is noted down. My initial reading is 2.1. Remember this, that don't forget to write the burette reading in 2 decimal places. It is your one of the marks in the the first column, that is the 7 marks of the first part, that you will get 1 mark for writing the burette readings in 2 decimal places. Okay. The next part is this, that you are going to take 25 cm cube of Fa1 into a conical flask. Pipette out this, the 25 cm cube. The exact volume of 25 cm cube is to be taken. Place the pipette filler. Make sure that the no air should be there in the bulb, right? And do not press this too hard that the ball inside it just gets dislocated. Okay, so 25 cm cube of Fa1 is to be taken. Now remember this, that this is a colored solution which you are taking out. You are pipetting out a colored solution. So you must be noting down the upper meniscus of this solution. And the level of the solution should be at your own eye level. Since this is a colored solution and you have to be very careful in it. Okay, so this is your 25 cm cube of potassium manganate 7. Now use the measuring cylinder to add 10 cm cube of Fa2. This is the Fa2 solution, which is potassium iodide, and 10 centimeter cube is to be added into the conical flask. Now here we will be noting down the lower meniscus, as this is the colorless solution. And now use the measuring cylinder to add 15 cm cube of Fa4. Fa4 is the sodium thiosulfate. Fa4 is the sulfuric acid. And we are going to add 15 cm cube of this. And again we are going to measure the lower meniscus. For all colorless solutions, you have to note down the lower meniscus, and for the colored solutions you have to note down the upper meniscus. Add this sulfuric acid and you can see that there is a reddish brown color that is being formed because iodine, and you can also see the solid particles of the iodine in it. Now your solution has been formed in which this iodine has been liberated. KMnO4 has reacted with potassium iodide and the iodine has liberated, and it has turned the solution a reddish brown in color, and there are the solid iodine specks also that is being formed. Now we are going to perform our rough titration. We have noted the initial reading as 2.1, and now carefully holding the titration flask in your right hand and operate the burette with the left hand. You will add sodium thiosulfate from the burette till the solution becomes yellow. It means that some of the iodine will be reduced by the sodium thiosulfate solution. Keep an eye on the solution and keep on adding till the solution becomes yellow. That is when the reddish tinge of the iodine has disappeared. This is the moment where the reddish tinge has disappeared, and now I am going to add the starch indicator. Here they say that add several drops, which means that I am going to add approximately 10 drops. 3, 4, 5, 6, 7, 8, 9, 10. Okay. The iodine has made the starch iodine complex, and that is a blue-black color. Now we will continue titrating, and this is going to give you a sudden color change, so you have to keep the flow of the titer dropwise. There is a sudden color change and you have to note down that the color change has occurred. So note down the volume, that is 21.4. Okay, so my final burette reading is 21.40. So here note down the volume of the Fa3. It is 0, 3 and 19.3. I got 19.30 as the rough titer. Now I'm going to rinse this conical flask. I'm going to rinse this conical flask and going to redo this titration second time, and will get the second reading that will be my first accurate titer value. Accurate titer, the first accurate titer, the second accurate titer, and then the third one if it is required. Remember that once you have done with the rough titer, you will be doing these and you are doing the accurate titration. You have to be very careful, at least 2 centimeter cube before the rough titer has been obtained, so that you get the exact titer value. You have to be very precise in getting the reading, because the maximum difference between the two titer values should be 0.1 cm cube and not more than that. It is preferable that it should be the accurate value. Okay, we will do the calculations later on. Thank you very much.